Hello guys, welcome back to my YouTube channel. Today I am going to solve day 15 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now, without any delay, let's get started with today's problem. So today I am going to solve problem number 2812. Find the safest path in a grid. Okay, so in this problem, you are given a zero indexed 2D matrix grid of size n into n, right? So this is one grid matrix given to us, right? So here a cell containing a thief if the value of grid RC is 1. Okay, so in this grid, if any cell is containing 1, that simply means that in that cell there is one thief. Okay, and if any cell value is 0, that simply means that there is no thief in that particular cell. Okay, so you are initially positioned at cell 0 by 0. Okay, so initially you are going to start from this cell, this 0 by 0 cell. Okay, and in one move you can move to any adjacent cell in the grid, including cells containing thieves. Okay, so what is adjacent cell? Okay, so an adjacent cell of a cell RC is one of the cells. Okay, so let's say my RC right now I am at this. Okay, my RC is this is row and this is column. Okay, RC is this. So adjacent cell is nothing but RC plus 1. So that simply means this cell. If I am at this position, then RC plus 1 means this cell, RC minus 1 means this cell, R plus 1C means this cell, and R minus 1C means this cell. Okay, so I hope that you guys are clear. Okay, so from a particular cell we are going up, or we are going to the right, or we are going to downwards, or we are going left. Okay, if possible. Okay, if it exists. Okay, so I hope that this line is clear. So the safeness factor of a path on the grid is defined as the minimum Manhattan distance from any cell in the path to any thief in the grid. Okay, so we have to just return the maximum safeness factor of all the paths leading to the cell n minus 1, n minus 1. Okay, so this is my source 0 by 0, and this is going to be my destination n minus 1, n minus 1. Okay, so how we are calculating Manhattan distance? Okay, so Manhattan distance between two cells A and B, x and y, is equal to mod of A minus x plus mod of B minus y. Okay, where value is denotes the absolute value of the val. Okay, so before starting the explanation of the approach that I'm going to use, let's write few things that we already know. Okay, so few things that we already know are like the adjacent cell which we are going to move. Okay, so we know how to check whether our adjacent cell is valid or not. Okay, so for that I am going to simply write a few lines of code. Okay, some few very simple line of code. Okay, so first we know there are total 4 directions. Okay, up bars, down bars, left side or right side. Okay, so here what I'm going to do, I'm going to create one int array. Okay, int array of directions. Okay, so here int array of directions that I'm going to create. So it is a 2D array. Okay, and here I'm going to just declare the directions that I want to take. Okay, directions. So what are the directions? Okay, so directions are nothing but if I want to stay in that particular row. Okay, so just listen carefully. If I want to stay in that particular row and I want to move to the left side, so I have to write -1. Okay, 0 means there is no change in my row, -1. Okay, so this is row and this is column. -1 means I am going to the left. Okay, this is clear, right? After that, if I want to stay in the same row, but want to move to the right side. Okay, so here I am writing 0 1. Okay, so here simply what I'm going to do, r plus 0 is 0, c plus minus 1. Okay, so I'm just going to add r and c every time in these four directions. Okay, which will give me the directions which I want to go. Okay, so just write these few lines. Okay, so my if I want to move to the up direction, so minus 1. Okay, one row back and same column. Okay, so for that I am writing minus 1 comma 0. Okay, if I want to move one cell down, so here I am adding one row 1 and same column. Okay, 1 0. Okay, so I hope that this simple line is clear. Okay, okay, this is done. This is done, right? Now after that we have to check whether the path that we are taking is valid or not. Okay, so for that I am just going to create one method which we are going to use in our code later on. Okay, so boolean is valid. Okay, so this method is just going to check if the path that I am going to take, like upwards. Okay, so let's say if I am at this particular cell, so if I am in that particular cell, then I can't move upward because it will give the boundary conditions. Okay, so I have to create one method which is going to check the boundary conditions for me. Okay, so here I am passing int I, that's nothing but the row in which I am, int j, which is nothing but the column in which I am, and int n is nothing but the size of my grid. Okay, okay, so I am using these three variables. Okay, and here I am just returning, okay, if I is greater than equal to 0. Okay, and my I should be less than n. Okay, this is a very simple piece of line, right? J should be less than, j is should be greater than equal to 0, and j is less than my n. Okay, so if all these conditions are true, then only we are going to return true, otherwise we are going to return false. Okay, so so we don't need to check upwards if any condition is false here. Like here, if I move upward, then my I is minus 1. Okay, so definitely it is going to fail. Okay, so I don't need to check. So I hope that you guys are clear with these two pieces of lines, right? And here the n that I'm using. Okay, so I can simply write here, this is my main code. Okay, so here I am going to write int n is equal to grid dot length. Okay, simple, grid dot. Okay, so this is a list now, this is a list of integers, so I don't want to use a length. Okay, this is not array, so here I am going to write size. Okay, so this is going to give me the size. Okay, so I hope that this thing is clear. Okay, so now let's understand this problem with an example. Okay, so first let me copy this example in a new tab. Okay, so this is example 1. Okay, so first thing that I am going to do, I am going to create one safety array. Okay, safety 2D array. Okay, and this safety 2D array is going to contain the closest distance to a thief. Okay, so I'm going to create one 2D array. Okay, and that 2D array is going to create store the closest distance to the thief. Okay, so let's create one 2D array. Okay, after that I will show you how I'm filling the values. Okay, so this is my safety 2D array. Okay, and just pass the same size and okay, and also we have to use one queue. Okay, and in this queue we are going to store integer array type data. Okay, queue new linked list. Okay, this is done. Now after that just tell me. Okay, so this is my safety 2D array. Okay, this is my safety 2D array. Okay, so tell me if I am at this particular cell. Okay, if I am at this particular cell, then what is the safety distance of this cell from the thief? Okay, so since thief is already present in this particular cell, so safety distance that I am going to write here is nothing but 0. Okay, so I hope that this is clear. Okay, so now what I'm going to do, I am just going to fill the safety distances, and I'm going to use the queue to fill the thief positions. Okay, so first just let's do one thing. First just write the safety distances. Okay, so for this thief is already there. Okay, so I'm going to add 0. Okay, and in this cell, okay, in this cell thief is not there and value is 0. Okay, so in that case I am just going to store integer dot max value. Okay, I am just going to store integer dot max values here. Okay, for this one also I am going to store initially integer dot max value. For this cell, integer dot max value. Okay, integer dot max value, and for this one as well, integer dot max value. For this one 0, for this one 0, and for this one integer dot max value. For this one, sorry, for this one I have to store integer dot max value. Okay, integer dot max value, and here 0. Okay, so this is what I need to do. Okay, so here I am going to initialize safety distances and fill the queue with the thief position. Okay, so I am going to run one loop for int I is equal to 0, I is less than n, I plus plus, for int j is equal to 0, j is less than n, j plus plus. Okay, since we are using list, so I have to write like this: if grid dot get ith row and get the value of dot get of j. Okay, so if for this particular cell, if my value is equal to 1, okay, in that case I have to fill this safety array value as 0. Okay, and I have to I have to fill the queue with the thief positions. Okay, so queue is of int array type. Okay, so what I am going to do here, queue dot add new int. Okay, new int. Okay, and in this array I am filling the values I, that is my row number, j colon number, and then after that 0 is nothing but the safety distance. Okay, so this is what I am filling here, and in the else part I am just assigning this safety or I of j value as integer dot max value. Okay, so I hope that this is clear until now what I am doing, right? Integer dot max underscore value. Okay, this is done. Okay, so till here we are good, right? Okay, so we have to return the maximum safeness factor of all the paths leading to n-1 and n-1. Okay, maximum safeness factor, right? Okay, so we have to find the safety distance, right? But if I am starting from this particular cell, okay, this condition is given that every time I have to start from this particular cell, and thief is already present in this cell, then where is my safety? There is no safety, right? So in that case we have to simply return 0. Okay, okay, so I hope that you guys are clear. Okay, I am starting from this cell and thief is already present in this cell. Definitely he is going to rob me, right? So I don't so there is no safety, right? So in that case I have to just simply return 0. Okay, and let's suppose if in this cell 0 was there, okay, then in that case also I have to reach in this position in the end. Okay, so if the thief is present in the end position, then in that case also I have to just return 0. Okay, there is no safety, right? Okay, so if the thief is present in this cell 0 by 0, or if the thief is present in this cell n-1, and minus 1. Okay, in that case we have to simply return our output as 0. Okay, so I am going to write the same thing. Okay, so if start or end cell contains a thief, return 0 immediately. Okay, then we don't need to check anything. Okay, so I am writing this base condition. If grid dot get 0, okay, dot get 0, then in that case, okay, so if this is value is equal to 1, okay, and or if my grid dot get n minus 1 dot get n minus 1, okay, if these two values are equal to 1, then in that case we have to just simply return 0. Okay, so I hope that this line is clear as well. Okay, okay, this is done. Then after that, okay, so that's the reason that in example 1 we are simply returning 0. Okay, so now let me pick this example. Okay, example number 3. Okay, let me copy this example. Okay, so this is my example 3. Okay, so in this example first we are creating our safety array, right? So in safety array let me store the values. Okay, so this is how it looks like, right? My safety 2D array, right? This is how it looks like, and here we are storing 0, and here we are storing 0, and here we are storing the integer max value. Okay, on all the places. Okay, here also I am storing IM. So now I have filled my safety matrix. Okay, so see in this cell and in this cell value stored is 0, and in all other cells we are storing integer dot max value, right? So this is done. Then after that we are also adding the queue, right? We are also adding the queue, adding the values of those cells in which the thieves are present. Okay, queue dot add. Okay, so in queue what I am storing, I am storing what is the row of this thief. This thief is present in 0th row, and what is the column? Okay, so this is 0th row, first row, second row, third row, 0th column, first column, second column, third column. Okay, so in queue I am going to add 0, 3, and safety distance for this one 0, 3, 0. Okay, this is one thing that I am adding in queue, and this is one more thing for this thief. I am adding this one as well in my queue, right? This thief is present in third row, 0th index, and safety distance is 0. Okay, this is what I am filling till here, right? Okay, so this is clear. Then after that what we have to do, after that we have to use a multi-source BFS to calculate the minimum distance to a thief from all the cells. Okay, so we have to just calculate the minimum distance of to a thief from all cells. Okay, so from this cell, okay, so let's say initially my thief is present in this value. Okay, initially my thief is present in this cell, right? So right now, okay, my thief is present in this cell. Okay, so my current x value is this 0, my current y value is nothing but this, and my current safety value is nothing but 0 only. Okay, there is no safety, right? I am starting from this cell. Okay, so now I have to check in all the directions. I have to check in all the directions. Okay, so next direction is okay, so there is one directions array that we are using. Okay, so let me just copy this piece of line here. Okay, so this is a directions array that we are using, right? So here what I'm going to do from this cell, okay, so from this cell, okay, I want to move in all directions. Okay, so first I'm going to check if I can move in this 0, 0, -1. Okay, so this value is 0, Okay, so in this 0, if I add 0, then simply means there is no impact, right? 0. And if in this 3 I am adding this -1, then this will become 2. Okay, so I am moving to 0 by 2. Okay, 0 by 2 simply means that I am moving to this cell. Okay, so I hope that this is clear now how we are using. Okay, 0 2. Okay, so now I am moving in this value 0 2. So now for okay, after moving this, I have to check first if it is valid. Okay, yes, this is valid. Okay, this is valid, we can move to this side. Okay, so that is why I am writing this valid function now. So first I'm also validating this. Okay, so this is valid, right? Then after that, in this cell I am going to update the current safety value as 1. Okay, since this cell is at just one distance. Okay, this cell is at just one distance from this one, so here I am going to add the current safety value as my original current safety 0 plus 1. Okay, so this is what I am going to add here, 0 and 1. Okay, from this thief. Okay, then after that okay, so this is done, this is done. Then after that I have to check in all the directions, right? So from 0 to 1, if I'm in the same row. Okay, so this is 0 3 0 plus 0 0 and 3 is 4. Okay, so I can't move in this direction, right? I can't move in this direction. Okay, so this function will return me false. Okay, so I don't need to do anything here. Then after that, okay, after that I have to check in -1 0. Okay, so 0 minus 1 is nothing but -1, and 3 plus 0 is 3, so -1 3. That simply means I want to check here somewhere here upwards. Okay, but this function will return false, so I don't need to do anything. Then after that 1 0 1 0 simply means 1 3. Okay, 1 0 and add 0 3 here, so it will become 1 3. So 1 3 means simply this cell. Okay, so in this cell I have to update the value of safety as 1. Okay, I have to update the value of safety as 1, and every time one more thing that I'm doing here. Okay, I'm updating the safety distance as well. Okay, first I am removing this from my queue. Okay, I am removing this from my queue. This is my current cell, and here when I reach at this position, I am adding the safety distance, but I am also adding this cell in my queue side by side. Okay, so tell me where this is present. Okay, at what value? Okay, so this is present in 0 2, and the current safety is 1. Okay, 0 to 1. Okay, this is what I am adding side by side, and for this one I have to add like this. This cell is present in row 1 and column number 3, and safety is 1. Okay, so step by step I am adding. Okay, then after that I have to check for this 300. Okay, so for 300 I have to update this as 1. Okay, and I have to add this in my queue. So where this is available? This is available in this position, 2 row, column is 0 and safety is 1. Then from 0 I can go to this direction as well. So for this I have to update this as 1, and I have to include this in my queue as well. So row is 3. Okay, row number is 3, and column number is 1, and safety is 1. Okay, so I hope that you guys are clear what I am doing here. Okay, so I am moving in all the directions, and I am adding them in queue as well. Okay, then this is done. Then after that for 0 to 1 I have to check. So this is 0 1 2 3, this is 0 1 2 and 3. Okay, now after that for 0 2 and 1 I have to check. Okay, so from this I have to check for the this value and for this value. Okay, so I'm just filling this safety matrix every time. Okay, I'm just filling the distances. Okay, so for 0 to 1 I have to check. Then I am going to reach here, this will become 2, this will become 2. Okay, both of this cell will become 2. Okay, the values will become 2, and then after that I have to add this one as well in my queue side by side. So here I am adding 0 1 and safety is 2. Then for this one I have to add, so for this I am going to add it like this: 1 column 2 and safety 2. Okay, this is done. Then for 131 I have to update, so 131. Okay, this is my 131. Okay, 131. So for 131 I can move in this direction or I can move in this direction. Okay, so this will become how much? This will become 2. Okay, current safety, I'm just adding the current safety now. Current safety, old current safety was 1, now it will become 2. Okay, so this will be modified to 2 and this will be modified to 2 as well. Okay, this will be modified to 2 as well and this will also modify to 2 as well. Okay, so in this way we are calculating the safety. Okay, so just do one thing here, just tell me what is the distance. This is present in this 1 row and 2 column, and my thief is present in this 0 3. Okay, so let's do the Manhattan distance. 0 minus 1 mod plus 3 minus 2 mod. What is the value you are getting? You are getting 2 only, and that is why that's what I am updating, right? Using Q, that's what I am updating. Over here 2 is there. Okay, then this will become 2. Okay, so in this way we are going to fill this. Okay, so I hope that you guys are clear. So I'm just going to write the code for this part, this specific part. Okay, how I'm filling all these values. Okay, so yeah, that you guys will get more clear understanding. Okay, so initially we have these two elements in our queue, right? So that we have added here. Okay, so what I'm going to write here, while my queue is not empty. Okay, so I have to execute my loop until then. Okay, so inside this I am going to create a array, and in this array I am just passing the values of my queue. Okay, queue dot poll. Okay, so I am just passing these values right now, 0 3 0. Okay, this is one dimensional array na? In this I am passing the 3 values, 0 3 0. Okay, 0 is what? Current value of x. Okay, so here I am writing int cur x is equal to, it is present in 0th index, and my cur y is present in the first index, right? And my current safety is nothing but cur 2. Okay, this is what we are clear, right? Now I have to move in all the directions, upward, rightwards, downwards, all directions. Okay, so I am going to use for each loop for int in the directions I have to search. Okay, so I am just going to iterate one by one. First I am going to pick this one, 0 minus 1, then after that I am going to pick 0 1. Okay, so what is the name of this one? This name is directions. Okay, so let me copy it. Okay, so I am going to select all the directions. Okay, one by one. So next direction that I want to move, so next x. Okay, so in current x, okay, I have to add the value of direct dir 0, right? So in row I am adding this 0 now. In column I have to add this -1 first time. So int next y. Okay, so I hope that you guys are already clear what I am saying, right? Cur y plus 1. Okay, this is done. Let's write it like this, it will cool, right? So this is done. Then after that I have already declared this function method, right? Whatever you want to say, method, okay, is valid. Okay, so I want to check if these coordinates are valid or not. Next x and next y coordinates are valid or not. Okay, so I need to check this, right? So here I am just going to write if is valid. Okay, and in this is valid method, what we are passing? We are passing our row, column and total size. So here I am just going to write this coordinate is nothing but my row, right, my column, and what is my total size, and done. And then after that we have to check if safety, okay, this is one important line, safety of next X and next Y, okay, if the safety of next X and next Y is greater than, if it is greater than my current safety plus 1, okay, current safety plus 1, if it is greater than this one, then in that case we have to add that in our queue dot add new int, and in the queue what we are passing? We are passing the values of next X, we are passing the value of next Y, and we are passing the value of current safety plus 1, right? This is done. And in safety array, okay, next X, I'm going to update the values of next X and next Y as well, right? Next Y is equal to current safety plus 1, that's it, plus 1, okay. So this is what we are doing here, okay. So let me format the code, okay. So this is my while loop, okay. So let me copy just this piece of code, okay. Okay, so let's do one thing here, let me paste it here, okay. So initially, see, initially my queue, in my queue there are total two values, right? This 030, the thief is present in this index 03 and 0 and 300, okay. So initially current X is, I am just going to pull this element 030, I'm going to start from here 030, okay. So this is my grid, right? So here from this I am going in this direction, okay. So I am going to update here this value is integer max value, I am simply means integer max value, okay. So safety of next X next Y, okay, this one is infinity, na, max value of integer, max value of integer. So what is the max value integer, okay. So let's say that this is in max value of integer, so definitely this value is greater than, what is my current safety? Current safety value is 0 plus 1, yes, it is greater than, right? So I am operating it as 1, okay. So I hope that this is clear. I am operating it as 1 and I am adding this in my queue, okay. Next X next Y, current safety plus 1, 0 plus 1, I am adding this in my queue, okay. This is done. Then after that in this direction, if I go in this direction, so here also I am updating the same thing 1 and I am adding this, right? So after that from this one, okay, I have to search, okay. From this one I have to search, I have added 0 to 1 and I have added 131, okay. So after that from this index, okay, after that I have to pull this element 300 and here I have added this as 1 and updated this as 1 and added these two values 201 and 311, okay. I have already explained, okay. I have updated these two values 1 because integer max value is, see, safety next x next y value was infinity integer max, so I am updating that as 1. Okay, 1 1. Okay, this is done. Then after that we reach at this position. Okay, now see carefully, 0 to 1. Okay, I am at this position 0 to 1, safety is 1. Okay, so here I have updated this as 2, right? And I have updated this one as 2 also. I have updated this one as, this value was 1. Okay, I have updated this as 2 only, right? I have updated this one as 2 only. Okay, so 0 to 1, after 0 to 1 I have reached at this position 131. Okay, so now for 131, okay, 131, if I go in this direction, then what are the values? This column row is 1 2, and safety value is 2 right now, right? Safety value is 2, and right now I am at this index 1 3, and safety is 1. Okay, I am at this cell, I want to go here. Okay, so in this cell, what is my safety? My safety is 2, and this 2 is greater than my current safety. Current safety is nothing but in this cell 1 1 plus 1 2. No, it is not greater than this. Okay, so in that case I don't need to add this in my queue. Okay, so I hope that this line is clear. I don't want to add this in my queue. And my safety of next x, okay, so I don't need to update both of these things. Okay, if my syntax is valid, right, that is why I'm moving in this direction. And safety of and next x or next y, it should be greater than my current safety plus 1. Okay, so if it is not greater than current safety plus 1, then I don't need to update anything. Okay, so I hope that this is clear. Okay, so we have to just calculate the minimum safety distance, right? So from this thief, I am at this index. Okay, let's say I am this value is 1 1 and 2. Okay, this cell 1 2, and there are total 2 thieves. Okay, one thief is present in this index 0 and 3. Okay, one thief is present here, and one thief is present here on 3 and 0. Okay, so let's do the Manhattan distance. 1 minus 0 plus mode of 2 minus 3. What is the value? Value is 2. And if I do here 1 minus 3, what is the value? 1 minus 3 mode plus mode of 2 minus 0. So value is 4. Okay, I have to just write the minimum safety distance. Okay, so I don't want to go near actually in any thief. Okay, so this thief is actually very far away. I have to take the concentration of the thief which is a little bit near to me. Okay, so I am worried about this thief. Now if I am at this cell, I am worried about this thief. I am not worried about this thief. I am more worried about this one. Okay, so that is why I am going to write here value as 2. Okay, and that's the reason we are not updating. Okay, that's the reason we are not updating it. Okay, so I hope that this line is clear. Okay, so here we are just finding the, in this while loop we are just finding the safety distances from the thief. Okay, minimum distance to a thief from all the cell. Okay, this is done. Then after that, okay, so let's do one thing. Let's fill this. Okay, otherwise it will create more confusion. Okay, let's fill this as well. So how it looks like, let me copy this. This is how it looks like. Okay, so here safety distance is 0, and for this one is also 0. Okay, both are 0. Zero, 0, and safety distance okay, for this one safety distance is 1, for this one safety distance is 1. Okay, and for him this one safety distance is 1, and this one safety distance is 1, right? Then after that from here if I go here, then my safety distance becomes 2. Okay, from here if I go in this place, then my safety distance is 2. Okay, then after that for this one if I go here, then I don't need to update anything. From here if I go at this place, then my safety distance is 2, and that is right now. See, 2 is the safety distance from this thief, right? This is done. Then after that from here if I go here, then my safety distance will become 2. From here if I go in this place, then my safety distance will become 2, right? From here if I go in this cell, then my safety distance will become 2. Okay, this is done. Then from here minimum, we have to just calculate the minimum na. So just calculate, this is my 0th row, first row, second row, third column, third row, 0th column, first column, second column, third column. Okay, so calculate the Manhattan distance. Okay, from for this cell and for this cell, what is the Manhattan distance? So it's going to be 3 only, right? 3 only. So distance 3 only na, from both the thieves, minimum distance. We have to just consider the minimum distance. Okay, so for here at this position, okay, if I am at this position, then this cell number is 11, and one thief is present in this index on 0, 3, and one thief is present in this index in index 30. Okay, so let's do the Manhattan distance. The value will become 1 plus 2 is equal to 3, and for this one, 1 minus 3 is nothing but I'm going to write 2 plus 1, so 3 only. Okay, so from here also distance is 3. Okay, and for this part also we are going to get the same distance as 3, and for this part also we are going to get the same distance as 3. Okay, so I hope that this line is clear. Okay, so these are the safety distances. Okay, this is how we are going to fill. Okay, okay, so this is done. We have filled the safety distances. Then after that I have to use one priority queue. Okay, max heap in general for BFS from the start cell. Okay, so let's write the code. Okay, first to understand what I am going to do here. So priority queue, and in this priority queue we are just going to pass integer type path. Okay, in this path array I have to actually store all these things like safety distances, row and column. Okay, so new priority queue, and you guys already know that by default in Java if we don't declare compare method, then it is going to be treated as min heap. So since we need a max heap, so what I'm going to do here, so okay, so here if there are two values, okay, if there are two different values, okay, so here I'm just going to follow the path. Okay, I'm just going to consider the value, the safety distance which is greater. Okay, this is what I need to do. Okay, so integer dot compare, and here after that I have to pass b2 comma a2. Okay, so I have to just compare. Okay, so this is just going to sort them in descending order, right? So this is my priority queue for BFS from the start cell. So here first thing that I have to do in the path dot add. Okay, so in the path I'm just going to add, because we need to start from the first position 0 by 0 cell, so that is why this is my path. Okay, I have to build the path right now. I am going to build a path, so I am starting from 0, and what is my safety distance? So safety distance, in safety distance I'm just passing safety 0 by 0. Okay, 0 by 0. Okay, so I hope that this line is clear. Okay, So this is what I'm passing, safety. So for this path, what is safety? Safety is 3, right? Then after that, I have to create one boolean visited array. Okay, boolean visited array, new boolean, and give the same size. Okay, we don't want to visit same path, right? I don't want to do like this. Okay, if I go from this path to this path, I don't want to return to same path again and again. Okay, that is why I'm going to use this boolean based array. Okay, and initially since we are at this cell, okay, 0 by 0 cell, so I'm just going to mark this as true. Okay, I am marking this as true. Then after that, we have to use BFS to find the maximum safeness factor path. Okay, so we have to just follow that path in which we have maximum safety. We have to just follow that path in which we have maximum safety. Okay, and I can just go in these directions, in 4 directions. I can't go adjacently way. Okay, I can just go in these 4 directions. I can't go like this. Okay, so I have to just follow, I have to use BFS to find the maximum safeness factor path. Okay, so here what I'm going to write, while my path is not empty. Okay, initially I have added these values, right? So if while my path is not empty, okay, so here I am writing while my path is not empty. Okay, then inside this, let's create same way what I did here. Okay, so same thing that I'm going to, so let's copy this now, same thing. Okay, so same thing I'm copying here. Current x, current array is equal to q dot poll node. Yeah, I have to use here path dot poll. Okay, I'm going to access the elements of path. Okay, 0 0. Okay, so this is current row, this is current column, and what is the safety. Okay, so I hope that this lines clear, right? Then after that, uh, if we reach at the end cell n minus 1 and minus 1, then in that case we have to just return the current safety, and I have to maintain the order of this current safety. But in just in case, okay, if there is one single row, okay, if there is one single cell, 0 by 0, this is 0 by 0, and actually this should not be the case, but just say, and this is also n minus 1 and n minus 1, then in that case we have to simply return the current safety, right? If I am at this position, we have to just return the current safety. Okay, so what I am writing here, just writing one base condition: if we reach the bottom right cell, return the current safeness factor, right? Okay, so here I am going to write if current x is equal to n minus 1 and current y value is equal to n minus 1, then in that case we have to just simply return the current safety. Okay, now just few lines of code is pending. Okay, so we are just returning the current safety. Okay, this is done, and then we have to explore the adjacent cell as well. Okay, so I have to move in all the directions. So same code, I have to move in all the directions, right? So here int next x is equal to current x plus direction 0, current next y is equal to this. Then again we have to check if this is valid, and okay, so here after that again we have to check if the next coordinates are valid, and we haven't visited that cell. Okay, this is new thing that we have to add. Next x, and here we have to write next y. Okay, if we haven't visited the next cell, next y. Okay, this is done. Okay, then in that case we have to add that path.add. Okay, if we haven't pasted that, then in that case we have to add that path.add new int. Okay, and in this path I am adding the coordinates, next x, next y, and here we have to add the minimum. We have to add the minimum of current safety. Okay, because in the end we have to return the current safety, right? So we have to just add the minimum current safety. Okay, this is what we need to return. We have to return the minimum safety. Okay, minimum safety. So this person is going to say that I was in the thief cell only, so there was no safety, so I'm returning 0. This person is going to say that I followed this path and this 2 is the minimum distance that I have come across. Okay, so this 2 is the minimum distance from the thief. Okay, so we have to just return the minimum distance from the thief. Okay, we have to follow one path and we have to just return the minimum distance. Okay, so here current safety. Okay, so here current safety is little bit comprised. Okay, so this is a minimum current safety. Okay, that's what we are returning. So current safety comma safety of next x next y. Okay, so here just add next x and next y. Okay, this is done. Then after that, in the end we have to just mark our this visited cell as true. Okay, so what I'm going to write, I'm going to write visited next x next y as true, and in the end we have to just return 0. Okay, if we don't get any results, so we are just going to return 0. Okay, so now let's run the code and see if there are any code issues. So yes, there are some code issues, so let's try to resolve them. So line number 40 we have missed, I think, next y. Okay, so this is done. Let's run the code again. Okay, so in priority queue int path is equal to new priority, spelling mistake, priority, priority, priority queue integer dot compare. Okay, let's run it and see if there are any other code issues. So all the test cases has been accepted, right? All the test cases has been accepted. Now let's submit it and see the runtime. So see, our solution is accepted, right? And it beats approximately 98.36% of the users with Java, right? So see, let me go through the code once more. So this you guys already cleared that there are total 4 directions. Okay, that's what I did here. Then there is one is valid method. Okay, it is checking whether the next coordinates are valid or not. Okay, if it's not valid, then it's not going to perform anything inside these if conditions. Okay, so this is what we are checking here. Then we have calculated the size of the list. Okay, this grid, and then we are going to create one safety 2D array, and in this safety 2D array, if thief is present in any particular cell, we are just adding the 0 value. Otherwise we are just adding the integer dot max value, and we are also adding the queues. Okay, in the queue we are adding where our thief is located. Okay, if thief is located in a particular cell, then we are just adding the row, column, and safety for this. Okay, safety is always 0. Okay, if thief is there. Then this condition you already know that if thief is present in our starting cell or in the end cell. Okay, destination cell. Okay, so in that case we have to just return 0 because there is no safety, right? Then after that we are using this queue, right? We are checking this BFS method. Okay, here we are just filling the safety distances. Okay, so in this part this is nothing but a multi-source BFS to calculate the minimum distance to a thief from for all cells. Okay, minimum distance to a thief from all cell. Okay, so this is what we filled here. Okay, so from this cell what is the minimum distance? Okay, minimum distance 3. Okay, from this cell what is the minimum distance to a thief? 1. From this cell what is the minimum distance to a thief? 2. Okay, so you using Manhattan you can calculate. Okay, so using Manhattan you can calculate. Okay, so this where is this? So here in the problem statement it is given how to calculate the Manhattan distance. Okay, so this is simply I'm doing it with the code. Okay, I am doing it with the code. Okay, so every time we are just using the we are just adding the one in the current safety. Okay, if the safety next x and next y value is greater than current safety plus 1. Okay, so initially all these values was integer.max, that is why we are updating, and then later on I am adding these values in a queue as well. Okay, okay, so I hope that you guys are clear with this while loop. Okay, simple code. And then we are using priority queue, max heap in general. I have already arranged the elements based on their safety distance in a decreasing order. So that simply means that first I am going to process the cells in which safety distance value is higher. Okay, in which the safety distance value is higher, only that cells I want to process. Okay, so from 3 I can go to this 2, from 2 I can go to this 3, from this 3 I can go to this 2, this 3, this 2. This is one path, this is also one right path, right? But from here I don't want to go here. Okay, because the distance is very less. Okay, 1 0, so I am giving the priority to the cells in which safety distance is higher. Okay, so that is why I am reducing some runtime complexity. Okay, so here in the path I am starting from this cell, right? And I have to make note of the visited cell. So initially, since I am at this particular cell, so I am marked this as visited. Then I'm checking if my path is not empty. Okay, if my path is not empty, yes, in the path I have filled this value 0 0 and safety is 3, so I have filled all these values. Then this is the end condition. Okay, if I reach in the end, then I have to just return the current safety, otherwise I have to move in all directions. Okay, so next x current, okay, this one. So here, from here let's suppose I go to this direction. Okay, so for this direction I haven't visited that, so in the path dot add I have to add this path. Okay, so I have to add these values. Okay, initially my path is starting from 0 0 and current safety is 0. Then after that I am moving to this one now. So here I have to add like this 0 1 and the safety, how I'm calculating safety. So here math.min current safety is 3, and what is the safety of this particular cell? So safety of this particular cell is 2, so I have to just add the minimum. I have to add the minimum, so here I am adding minimum. Okay, next time I am adding minimum. Okay, from 2 I go to this 3. Okay, so here I am, how I am operating 1 1, and I am operating minimum. Okay, because here see, here after that I am updating that as minimum of current safety and safety next to y. I am following the path in which higher value is there, but I am maintaining my safety as minimum. Okay, because in the end we have to just return this now. So here I am maintain 2, here 2 2 2, here when I reach the current safety was 2 at that point, so I have to return the minimum, right? So this was the minimum distance. Okay, this was the minimum distance when I was not safe, not much safe. Okay, if I follow this path, then this is a minimum distance, this is a minimum distance, this is a minimum distance. Okay, when I was not much safe. Okay, minimum distance to the thief. Okay, so I hope that you guys are clear with today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Okay, till then, keep coding and keep practicing. Meet you guys in the next video. Thank you, bye bye.